Hi everyone, my name is Paragpal and welcome back in lecture number 2 of Design Strength of Bolt for Tension and Bearing. So this lecture will define you what are the formulas that you need to focus for the design calculation of the strength of the bolt in the tension and the bearing. So before proceedings for the numerical, it is very important to understand the formulas because in the steel structures you will be facing lots of problem if you did not properly understand the formulas. Okay, before proceeding towards the numericals, let's understand the formula importance, right? So this video will help you to understand what are the formula for the design strength of bolt in tension and bearing. So we'll start with the tension first. Now you can see the formulas for the tension is represented by T and TB. Okay, so we are representing the formula for the design strength in T and TB, whereas it is 0.9 FUB AN, okay, which is less than equals less than, okay, FYB ASB in bracket partial safety factor gamma MB upon gamma MO, right? So this is a total formula. This is a total formula. Okay, now in this formula there is a two conditions that we have identified. Okay, 0.9 FUAN, this is the first condition and this is the another condition. Okay, so this formula work in a condition base wise. Understand? Now what are the things that we have considered here? So AN is a net tensile area as specified by the IS code 1367. Okay, for all bolt, like wherever there is a tensile stresses which is not defined, okay, small be the area of the root of the thread we need to consider. Okay, so I'll do that one while the numerical solving. Okay, so AN is the, you can say, the net tensile area. Okay, now ASB, which is defined here, okay, this is a ASB, this one. So it is a shank area of the bolt, right? FUB is the ultimate tensile strength. This is the FUB, ultimate tensile strength of the bolt, and FYB, this one, is the yield stress of the bolt. So all these things are mostly given or you need to calculate. Okay, so I'll explain you how you can do that one. Now whenever you calculate the tensile forces, if you wanted to make them factored, okay, so there is a formula TB which is greater than which is less than equals to TN TB divided by gamma MB. So whatever you are going to calculate TN TB, if you make it factored, divided by that should be greater than or equals to the TB. Okay, the factor tensile force. So for that you need to divide it by partial safety factors. Okay, now if I just go for the calculation in the bearing of the bolt, so if you wanted to do a design of the strength of bolt in a bearing, so what you have to do, there is a formula such as design bearing strength of the bolt on any plate, it is given by VDPB. Okay, so formula is VNPB divided by gamma MB. Understand? Now, so if you wanted to do the calculation for the VNPB, for this one if you do a calculation, there is a separate formula. This is a separate formula I have provided here, okay, which is VNPB equals to 2.5 kb, okay, into D into TP into FU. Now you will ask me, sir, these formulas how we can understand? No worries at all. Whenever you are gonna visit for examinations, they will allow IS code 800/2007 for limit state of method, and these all formulas are mentioned there. Only you need to understand what are the things that you need to calculate properly. Okay, so don't worry, I'll help you how to guide, how to use all these things in your examination. Perfect. Now, so once the VNPB is given, so there is one of the very fundamental term which is a KB. Okay, so this KB you need to calculate. In design, KB is normally taken equal to the one unity, but for that we need to calculate in different way. The first one is E divided by 3 into DO. Okay, second condition, pitch divided by 3 into DO minus 0.25. Third condition, FUB upon FU, and third is a 1. Okay, that's why I say we consider as a unity, right? Now, so E and P, E is the end and P is the pitch distance of the fasteners, right, along bearing direction. So I'll explain you what exactly it is when we go for the numerical. Just understand now the conditions. DO is the diameter of the bolt hole. D is the nominal diameter of the bolt. FUV is the ultimate tensile stresses. Fu is the ultimate tensile stress of the plate. See here there is a difference. FUB for the bolt, fu for the plate, and this is everything given in your IS code, so no worry at all. Okay. TP, what is the TP? TP is nothing but the summation of the thickness of the connected plate experiencing bearing stresses in the same direction. So that is what it is very important. Understand? Now let's understand the design bearing strength of the bolt is calculated by VDPB, which is VNPB upon gamma MB. So once you calculate VNPB, okay, so VNPB, okay, so this VDPB we need to calculate. So for that VNPB, what we have calculated from here, okay, we need to divide that one with the help of the partial safety factor, right? So partial safety factor for the plate is, if you calculate the bolt in a bearing, it is 1.25, and VNPB formula already we discussed at the top, right? So VNPB should be multiplied by a factor 0.7. Remember this thing. Whatever the VNPB you are going to calculate, you need to multiply it by the 0.7 for the oversize or the short slotted hole. Okay, right? For the oversize, and whatever the short slotted hole, that you need to multiply by 0.5 for the long slotted hole. That is what very important information that you need to consider. So don't worry at all. Whenever we are going to go for the numericals from the next lectures, okay, you guys is gonna understand it thoroughly, and I'm gonna help you to understand it in a very simple manner. So I hope you understand this video. Have a nice day. Bye bye.